Good morning. Namaste. How are you?
Good morning and namaste, sir. I'm fine.
Sir. Good morning, sir. Namaste, sir. I'm fine. 1 minute, sir.
You completed your homework?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
1 minute, sir. My video.
Today we will discuss about LCM and HCF of algebraic expressions. We already have done a few questions on HCF, right? We will do some more questions on
Yes, sir.
LCM and HCF.
I can't see your video, sir. My
Reload.
video. Okay, sir.
Sir, I cannot see it either.
Yes, sir. No, also I cannot see.
You can see video or not?
No, sir. I cannot see.
Did you reload?
Yes, sir.
Anurag, can you see?
No, sir, I cannot see it.
Can you see it now?
Yes, sir.
Yes, sir.
My video is not turning on, sir.
It is your daily task.
Sir, now your voice is low.
Can you hear me?
Yes, sir.
Yes, sir.
So LCM and HCF of algebraic expressions. We will start with some numbers. Try to find LCM of 2, 3, 6.
Sir, it is 6.
It is 6, right?
Yes, sir.
And what is
Yes, sir.
HCF of 2, 3, 6?
Sir, 1.
1. Okay. So you are comfortable finding LCM and HCF of numbers, right?
Yes, sir.
Yes, sir.
Yes, sir.
We also have discussed about how to find HCF of algebraic expressions like 2x square, 3x power 4 and 5. Let's take 5 here, x raised to the power 5. What is HCF of these three?
Sir, x square is there, HCF.
What?
Sir, x square is there, HCF.
Okay. So you found HCF of numbers also 2, 3 and 5.
That's 1, sir.
Okay. X square is the HCF of these three expressions. So what we do is we take the HCF of numbers separately and then we take the HCF of variables separately. Now think of this. HCF of first is 3 times x square into x minus a whole square, and the other one is 6x cube into x minus a. What is HCF of these two?
Sir, 3x square bracket x minus a.
You said 3x square bracket x minus a.
Yes, sir.
That's right. Okay, so how do we do it? We take each item separately. First we consider these numbers 3 and 6. We take HCF of numbers. Then we consider x in them, like x square and x cube. We take HCF, and then we consider the next factor x minus a, which is here with power 2 and here with power 1. So x minus a with power 2 comma x minus a with power 1. Now we take HCF of these two as well separately. So we consider HCF of these all separately. HCF of 3 and 6 is 3. How to know? HCF means common factor, highest common factor. Factor means which can divide it. So if we make a list here, factors of 3. Factors of 3 means which number can divide 3 perfectly. Which number can divide perfectly is the factor. So in this place we can have 1, because 3 is divided by 1 perfectly. 3 is also divided by 3 perfectly. So factors of 3 are 1 and 3. Now we talk about factors of 6. Factors of 6. Similarly, the numbers which can divide 6 perfectly are the factors. Numbers which can divide 6 perfectly. So check which number can divide 6. 1 can divide 6, 2 can divide 6 in 3 times, 3 can divide 6 in 2 times, 6 can divide 6 in 1 time. So 4 factors, 1, 2, 3 and 6. So we look at common factor. F stands for factor, C stands for common, and H stands for highest. So let us first find out common factor. Common factor is 1. 1 is in both of them. Common factor is also 3. So 1 and 3 are the two common factors. But the highest one, we have to take common factor which is highest. That is of course 3. So 3 is the highest common factor of 3 and 6. Next, HCF of x square and x cube. How do we take HCF of variables? Simple idea is that you take always the least power, smallest power on the variable. First one is having power 2, x power 2. Second one, x power 3. the smallest power is 2. So you take x square, x with power 2, the smaller power of x becomes HCF. Same here, we have x minus a. First time it's with power 2, second it has power 1. We take the smallest power, as I said, the smallest power. So you take x minus a with the smallest power 1, and power 1 remains hidden, no need to show it, we don't write it, it is already there, we don't write but it is there, hidden. Okay, so we have taken HCF of numbers, first factor x, next factor x minus a. Now let's combine each of them together to get the HCF of all. 3 into x square into x minus a. So this HCF is correct. Got it?
Yes, sir.
Yes, sir.
Consider this x minus 2 into x minus 3 whole square, comma x minus 2 whole square into x minus 3. Take the HCF of these two expressions. What do you think is the HCF?
X minus 2 into x minus 3.
You said x minus 2 into x minus 3. X minus 2
Yes.
is the first factor. So here it is with power 1, that is hidden, no need to show. Here also we have x minus 2 with power 2. Smallest power is 1, so we will take it up in the answer. X minus 2 with power 1 is there hidden. Now we look at the second factor, x minus 3 whole square, x minus 3 power 1. Again we see this has power 2, this has power 1, we pick the smallest power. So x minus 3 with power 1 is written here. This is the correct HCF. Now try this, x minus a whole square, x minus b into x minus c, comma x minus a into x minus b whole square. Find HCF.
X minus b into x minus a.
minus a into
Okay, so we have to look at each factor one by one. First factor, x minus a. Here it is with power 2, here it is with power 1. So this factor x minus a will come with the least power, smallest power 1. We have x minus a. Now we look at the second factor, x minus b. Here it is with power 1 and here it is with power 2. And we take the smallest power while taking HCF. Smallest power 1 will come here. Now we look at third power, that is available, third factor available here, x minus c, but this is not available in the second one. Not available means what? Not available means it has power 0. That's why it's not available. Anything which has power 0 vanishes because its value is 1.
Okay.
X minus c is not visible in the second expression. That means it has power 0. You cannot continue without video. Go out and join. Make it correct, David.
Okay, sir.
X minus c with power 0 is here and power 1 is here. We will pick the smallest one. So we will pick x minus c with power 0. Smallest power 0, here it is 1. Now if we pick a smallest power 0, so what will happen to it? The same will happen that happened here, means it will vanish, because it was vanished because of power 0, it was not visible. Here also it will not be visible. Done. So it is the correct HCF. Okay.
Okay, sir.
Now we have take HCF of these two. Try to find HCF of this and this. There are two expressions.
Sir, bracket x plus 1.
What did you get?
Sir, x plus 1.
X plus 1.
Yes, sir.
Are you sure it is correct?
No, sir.
See, in this one, we have quadratic factor and we don't know what are the linear factors for it, which two factors it contains. X square minus 5x plus 6 is a quadratic factor, quadratic polynomial, and it has two factors. Which two factors? We don't know. Here also it will have two different factors. We don't know. Till the time we know the factors, linear factors of it, we cannot make final decision. So let us first know what are the factors. Factorize and let me know what are the factors for the first one. Do quick. Do quick, I am waiting.
Sir, x. Yes, 1 minute.
Take your time and do it.
Sir, the first factor is x minus 3 and the second is x minus 5.
X minus 3 and x minus 5.
Yes, sir.
What is 3 times 5?
Sir, 15.
Do you see 15 there?
No, sir.
If you write x minus 2 and x minus 5, x minus 3 and x minus 5, want to multiply 3 with 5? Do you have 15 there?
No, sir.
Have you learnt it? Have you
I
learnt
Yes,
could,
how to factor?
sir, it will.
sir, I could not fix.
Sir, it will be x minus 2 and x minus 3.
X minus 2, x minus 3. And what are the factors of the second? This?
Sir, x plus 3 and x minus 2.
X plus 3, x minus 2. Okay, that means the first expression has total 3 factors. First here, second this, and third this. First expression has 3 factors. Second expression also has it has 4 factors because it has power 2, so 2 factor here, third one and fourth one. It has 4 factors, it has 3 factors. We have to take HCF. So look at common factors. X plus 1 is 1 time here, 2 time here. So 1 time is common, least power. We already have written x plus 1, that is done. Now look at x minus 2. Here it is 1 time, here also it is 1 time. We can take x minus 2 as well. Then we look at the third factor, x minus 3 is not available in the second, and x plus 3 which is available in second is not available in the first. Okay, so there is nothing common now. This is the HCF. Did you understand?
Yes, sir.
Yes, sir.
We can multiply them back to write the final answer. X plus 1, x minus 2, it's x square. 1 minus 2 is minus 1, so it's minus x, and then 1 into minus 2 is minus 2. We got the HCF, x square minus x minus 2. I means you have learned how to multiply such two brackets, right?
Yes, sir.
Like you
Yes,
add
sir.
a plus b, you do a plus b here, 1 minus 2 is minus 1, you write minus 1 with x, and then you multiply a and b, 1 into minus 2, that is minus 2, correct?
Yes, sir.
Well, so this was the discussion
Yes.
about HCF. Now let us talk about LCM. Our topic is LCM and HCF of algebraic expressions, not the numbers. We have discussed about numbers in the starting, but now we will be discussing about algebraic expressions. So let's take this: 2x square, 3x4, 5x power 5. 2x square, 3x power 4, 5x, what was that? Power 5. Okay, so at LCM, how to take LCM of these three expressions? Similar to HCF, you will take LCM of number part and variable part separately. You don't have to write all this, but this is something you have to keep in mind. First, think of numbers 2, 3, 5. What is LCM of these three? Tell me.
One,
Sir, 30.
1x square.
30. So we got the LCM of number portion. Now we take LCM of variables. X square, x power 4, x power 5. Do you have any idea how to take LCM of these variables?
No, sir.
Sir. No, sir.
M stands for multiple. Multiple is never smaller. Multiple is always greater or equal. What do I mean? See, if you take LCM of 2, 3, 5, which is the largest number? Largest number is 5. Largest number is 5. M stands for multiple. So remember, if you take multiple LCM of a few numbers, LCM can never be smaller than the greatest number. Largest number is 5, so LCM cannot be less than 5. It is always greater than 5 or equal to 5. Understood? LCM can be always either equal to or greater than the largest number. LCM is always either greater or equal to largest number. Does this make sense, this statement?
Yes, sir.
Yes, sir.
So it's a rule. LCM can never be lesser than the largest number. Largest number is 5. So here LCM cannot be lesser than 5. If we talk
Okay,
about
sir.
HCF of 2, 3, 5. In case of HCF, look at the smallest number. Smallest number is 2. So HCF cannot be greater than the smallest number. HCF is always smaller than the smallest number or equal to that. HCF is always lesser than or equal to the smallest number. Here smallest number is 2. So HCF must be maximum 2 or lesser than that, not greater than 2, not more than 2. Always lesser than.
Okay, sir.
HCF will be lesser than 2, lesser than the smallest number or equal to a smallest number. So that's a rule. You should remember this. That is important. Okay, so here we are intended to find LCM of these variables. What is the largest power?
X power 5.
Sir, x power 5.
Largest power. What is being asked? Be focused.
Sir, 5.
5 is the largest power. So LCM of these variables cannot have lesser than that power, cannot have lesser power than 5. So LCM is always taken with the highest power. So this is the LCM. As we know, LCM is always greater or equal, never smaller. So find out the greatest power, largest power 5 is there. So LCM cannot have the power lesser than 5. Got it?
Yes, sir.
Yes, sir.
Similarly, if you have first factor, say x minus 2 with power 3, x minus 2 with power 5, and you need to find LCM. Can you guess?
Sir, it will be x minus
Next,
2 whole power 15.
power 3.
Power 5, right?
Sir, 15.
15. Are you
Yes,
sure?
sir. No, sir.
L for least. L for least. Common multiple should be the least one, and the least one is this. X minus 2 power 6, x minus 2 power 7, x minus 2 power 8, x minus 2 power 9, x minus 2 power 10, and so on. All of these are common multiples. X minus 2 power 6 is a multiple of these two, both of these. X minus 2 power 7 is a multiple of both of these. X minus 2 power 8 is a multiple of both of these. See how that is multiple? Let us check. X minus 2 with power 7 is equal to what? X minus 2 power 3 times what? Guess. X minus 2 power 3 times what is this?
X minus 2 times power 4.
X minus 2 power 4. Okay. So this is
4.
what you multiplied. That means x minus 2 power 7 is a multiple of x minus 2 power 3. Yes or no?
Yes, sir.
Yes, sir.
That means each of these, all of these are, I mean, x minus 2 power 6, x minus 2 power 7, x minus 2 power 8, each of these are factors of, multiples of both of these. But we don't care of multiples. We don't care of common multiples. We only care of least common multiples. If the least one is this available, why will you take the greater power? If this one is the least power, why will you take the greater powers? You have to take least common multiple. So choose the least power that is common. X minus 2 power 5 is one time multiple of this one. Correct or not?
Yes, sir.
And x minus
Yes,
2
sir.
power 5 is also a multiple of this. Yes or no?
Yes, sir.
That
Yes,
means
sir.
x minus 2 power 5 is the multiple of both of these. So why not to take the least multiple? Why to take greater powers? They are of course multiples, but not the least. We have to take the least. That's why we take the higher power only. Power 3, power 5. Choose the higher power. That's it. Power 2, power 4, power 5. Choose the highest power. That's it. We always choose the highest power of the variable. It becomes LCM. And we choose the smallest power. It becomes HCF. Simple idea. Smallest power gives you HCF. Highest power gives you LCM. Did you understand this idea?
Yes, sir.
Yes, sir.
So now we will be taking all these questions to find LCM. Okay, one question is already pending here. Let's come here. We have to find LCM. So I will erase HCF and write LCM everywhere. LCM, LCM, yeah, LCM, LCM, LCM. Let's erase these answers because these answers were HCF. Okay, what is LCM of 3 and 6?
Sir, 6.
3.
What is LCM of x square and x cube?
Sir, X cube.
X cube.
And what is LCM of these two?
X
Sir,
minus
X minus
A
a
whole
whole
square.
X minus a whole square. Now think of the first question. You have to take LCM of 2x square, 3x power 4, 5x power 5. Try to write. Tell me what is LCM?
Sir, 30x power 5. Sir, it will be 30 and x power 5.
Okay, you said 30x power 5, right?
Yes, sir.
Correct. So you will take LCM of 2, 3, 5. LCM is 30. Now you look at the variables x square, x power 4, x power 5. We take the highest power of the variable. So x power 5 will be copied here. Done. This is the LCM. Now think of these two expressions. Try to write LCM. Tell me.
Sir, 6x cube bracket x minus a whole square.
Say again.
6x cube bracket x minus a whole square.
That's right. So
Minus
first we look
6.
at the number 3, number 6. LCM is 6. Then we look at the first factor x square and x cube. Highest power is power 3. So we choose that x power 3. Now we look at the third factor x minus a. Here with power 2, here with power 1. Higher is 2. Highest, we'll take that x minus a power 2 and it's done. Did you understand how to find LCM?
Yes, sir.
Yes, sir.
Okay. Give me a moment. Think of this. 2x square should be multiplied with what? To give 3x cube y square.
Sir, 3 by 2 x y square.
You said 3 by 2 x y square, right?
Yes, sir.
Okay. So when you multiply these two, 2 will cancel because numerator and denominator, x square into x will make x cube and y square will make y square here. Yes, that's right. And you could not do it, David?
Yes, sir.
Why? You don't know how to do?
I could not find, sir.
You know how to do or not?
No, sir.
Be simple to answer. If I ask you to multiply what equals 16, how will you do it?
8, sir.
What are you doing? What are you doing?
Hmm.
Don't you understand English?
I understand, sir.
I doubt. I didn't ask for the answer. Why you are telling me the answer? I asked how will you do? You don't know how to do this one as well. You did, but you don't know how you did. That means whatever you did was just an accident. You don't know what, you don't have any plan. Anurag, can you tell me how to do this?
So we will divide 16 by 2.
That's right. 16 can be divided by 2 to get this missing number. 16 divided by 2 gives us 2 8s are 16, it's 8. So that number, missing number is 8. So simple idea. Doing is not important. If you are not aware how you are doing, then it's a problem. You did, you think you have done it, you are intelligent. No, I don't consider you intelligent. If you do and you know how you did, then I consider you intelligent. Remember, every time think, if you do you know? Can you say it to someone? Can you explain it in words? If you cannot, that means you have confusing idea, and you can make it wrong anytime. You are at risk. You don't know how to say it to anyone, that means you are having confusing idea and it can be wrong anytime. You are at risk. You don't know the method. It's simple method. You can say 16 divided by 2. I asked how will you do it? Simple answer is that 16 divided by 2. You don't know this simple idea. Same idea can be applied here. I asked 2x squared times what is equal to this. You can divide it. 3x cube y squared. I have taken this expression here. I will divide it by the first factor. First expression, 2x squared. If I divide it, I see 3 by 2 will remain as it is because it's not getting cancelled. 3 by 2 will remain as it is. X cube by x square, according to laws of exponent, 3 minus 2 can be done. So x will come. 3 minus 2 is 1, so power 1 here. And y square will remain as it is. That's the answer. 3 by 2 xy square. Just doing is not important. Being aware of how you did is important. If you understand how to do, then very less chances there you will make mistake. If you cannot explain it to someone, if you cannot say it in words, that means you are confusing. You have confusing idea. X squared minus 5x plus 6 times what? Times what will give me x square minus x minus 6. Just a moment. It's plus x square plus x minus 6. Find out what will you multiply here.
Sir, I don't know how to do it.
You just gave up.
So minus 1 by 5 minus 1 will be there.
Say again.
So minus 1 by 5
Hmm.
minus 1.
What?
Minus 1.
Minus 4. This. Is this the answer according to you?
Sir, minus 1 by 5 minus 1.
Minus 1. This.
Yes, sir.
So why do you say that? If you have this answer, why don't you simplify it? 5 1 ja 5 plus 1 6. It's minus 6 by 5. Why don't you say this and then? Why do you say that complex thing? Why not simple thing? And that's a wrong answer. You just didn't focus over it. I have taught this already. And I am sure you know it. You were just absent of mind, that's why you couldn't do it. I have taught here how to find this missing factor. 2 times what is equal to 16. Missing factor can be found by dividing 16 by 2. I mean, the answer part should be divided by first factor to get the second factor. Answer part was 16. I mean, the product was 16. So, product should be divided by one of the factors. In this case, this expression into this missing thing equal to this. This is product. This second thing is product. And this is the first factor. Second factor is missing. Isn't it the same idea? If I say 2 times what equal to 16, are these questions different? Are these questions different?
No. No, sir.
It will look different if you're absent, if your brain is absent. If your brain is not working in the right direction, not thinking in the right direction, then it will make you feel different. But those who are focused will see them same. These questions are same. If this answer can be found by dividing 16 by 2, why not in this dividing the product x square plus x minus 6 by the first factor? If this rule works here, why not the same rule will work in the first one? If you are not seeing this, that means your brain is absent, not present there. Having confusing idea makes this type of mistakes. And those who are clear about the ideas cannot make this mistake. Now, how to divide is a part. How to divide it? It's very simple. We have factored them earlier also in the previous page. Here, x square minus 5x plus 6 has these two factors, x minus 2, x minus 3. And x square plus x minus 6 has two factors, x plus 3, x minus 2. So we can factor this. In the numerator it is x minus 2, x plus 3. And in denominator x minus 2, x minus 3. X minus 2 is a common factor, they cancel out. Just like here, 16 and 2, 16 means 8 times 2. And in the bottom, it's just 1 times 2. So common factor gone, 8 by 1 remaining, that means 8 became the answer. Same thing works here as well. Just like here common factor cancelled, here also common factor cancelled. What remaining is this. Now we cannot make it more simple, so it remains as it is. X plus 3 by x minus 3 is the answer. Here it should be x plus 3 by x minus 3. What is the difference between these two questions? Exactly the same way I did this, I did this. Tell me if you find any difference. If you give up so easily, you are called loser. You couldn't give the attempt, you couldn't think of the ideas. You just said, I can't. In that case, you are said a loser. If you don't know and if you ask how to do, it's not being loser. But you have the ideas, you are not just trying your best. That's being loser. If I tell you how to find this missing factor by dividing, why didn't you divide that by this? Here also I helped you to divide algebraic expressions this by this to find the answer. Okay. So now today's class ends here. We have discussed how to find LCM of algebraic expressions, HCF of algebraic expressions. We also discussed how to find missing factor. Missing factor. So 3 types of questions we discussed in today's class. I'll give you similar homework based on the things we have discussed already. For today, bye bye. See you in the next session.
Bye.
Bye, sir.